International Study Channel followers. How are you? Welcome to Facilities International Study Channel, Grade 12 Mathematics lesson in Ethiopian curriculum. This is Yamato. If you like the video, you can subscribe, share, comment, and like. This is binomial series. Binomial series ሲሆን ከዛ ፊት አውሩ የሚችለው subtopic is the binomial theorem አብረን ማየት ይጠበቅብናል ማለት ነው። So for a positive integer n and for any real numbers a and b is set of real numbers, we have an expression say a plus bx, the power of n is exactly equals to a the power of n plus, so a the power of n times a the power of n minus 1 times of bx plus here n times of n minus 1 bx squared over here 2 factorials plus here and again say n times of n minus 1 times n minus 2 times of say bx the power of say 3 over 3 factorial plus here n times of n minus 1 times of n minus 2 times of n minus 3 over 4 factorials here times of bx the power of say 4 plus up to say bx the power of say n. Look, we have an expression for any positive integer n and a and b is set of real numbers, so the expression a plus bx the power of n is exactly equals to a the power of n plus n times a the power of n minus 1 times of bx plus n into n minus 1 times bx square over 2 factorials plus n times n minus 1 times n minus 2 times bx the power of 3 over 3 factorial plus n into n minus 1 times n minus 2 times of n minus 3 times bx the power of 4 over 4 factorial plus up to say bx the power of n. Now here factorial means here plus the one here factorial here n factorial means here n times of n minus 1 times n minus 2 times n minus 3 times up to say 2 times say 1 ይሄ ማለት ነው n factorial ካሁን በፊት ታችኛው ግሬድ ይሄን ታውቁታላችሁ። So say for example here 2 factorial means 2 times 1 which is equal to say 2. 3 factorial means 3 times 2 times say 1 which is say 6. And 4 factorial which is exactly equals to 4 times 3 times 2 times say 1 በአንዳንድ እየቀነሰ ነው የሚሄድላችሁ ይሄ። ስለዚህ የእነሱን ፕሮዳክት ነው የምንወስደው ማለት ነው። Now 4 factorial means 4 times 4 minus 1 3 times 4 minus 2 2 times 4 minus 3 1 which is equal to say 24. And again say for example 5 factorial means 5 times 4 times 3 times 2 times say 1 because here 5 factorial which is n is 5, so n times 5 and again n minus 1 5 minus 1 which is 4 and again n minus 2 which is 5 minus 2 which is 3 and again n minus 3 5 minus 3 which is 2 and finally n minus 4 which is 5 minus 4 is 1. Therefore 5 factorial is exactly equals to 5 times 4 times 2 times 3 times 2 times say 1, which is exactly equals to 120. So በዚህ መልኩ ሌሎችንም ማየት መስራት እንችላለን ማለት ነው። with special condition, see the as an agreement, which is 1 factorial is exactly 1 and the 0 factorial is exactly say 1 as a special or as an agreement. Now, having this in our mind, when you come to here, our topic here say, which is the binomial theorem, says that for any positive integer n and a and b are set of real numbers, so a plus b x the power of n equals to, in such a form, in such a way, which means a the power of n plus n times a the power of n minus 1 times of bx plus n times n minus 1 times bx the power of 2 over 2 factorials plus n times n minus 1 times of n minus 2 times bx the power of 3 over 3 factorial plus n into or times n minus 1 times n minus 2 times n minus 3 times bx the power of 4 over 4 factorials plus up to say bx the power of n. Having this in our mind here, for a and b, since a and b is any real numbers, if a and b is exactly equals to 1, what will be happen here? So instead of a is 1 and instead of b is say 1, so the expression a plus bx the power of n becomes 1 plus x the power of n, 1 plus x the power of n. Therefore, here this is exactly equals to, say in this form, a, instead of a is here 1, so simply 1 plus n times, which is simply a is 1 and b is 1, therefore simply x, so here 1 plus nx plus here, and again n into n minus 1 times n, which is n minus 1 times of say x squared, simply x squared over 2 factorial plus n times of n minus 1 times of n minus 2 times of x to the power of 3 over 3 factorials plus, and again here n into n minus 1 times of n minus 2 times of n minus 3 times of x to the power of 4 over 4 factorials plus up to say x to the power of n, because of bx, instead of 6 b is 1, so it is simply x to the power of n. So this work is for what? Any positive integer n and a and b as a special case, which is say 1. But in general here in general for a and b as it is say 1, and for n is any real numbers, because here n is an integer, positive integer, but here for any real numbers we have this expression, that means the expression as it is say 1 plus x the power of say n is exactly equals to 1 plus nx plus n into n minus 1 times x squared over 2 factorial plus n times of n minus 1 times of n minus 2 times of x to the power of say 3 over 3 factorial plus n times n minus 1 times n minus 2 times n minus 3 times of x to the power of 4 over 4 factorial plus here up to say x to the power of n. Now, such kind of series is called this type of here. These types or kinds of series is called the binomial series. The binomial series. The binomial series. The binomial series. We call it such kind of series is known as the binomial series. From this we can suggest or reduce that the binomial series generalizes the binomial theorem. Here we can note that the binomial series generalizes the binomial theorem. ምን ማለት ነው? ይሄ binomial series generalizes the binomial theorem ያለው binomial theorem for it works for any positive integer ነበር እሱ ሊሰራልን የሚችለው። now ከዚህ በመነሳት for any real numbers any real numbers we can express the series in such a way that for this type of series is called binomial series. So this binomial series generalizes as the binomial theorem. And also for any n is an element of positive integer n. For n is the value of say positive integer then the binomial series reduced the binomial series reduced to binomial theorem. እንግዲህ አስተውሉ የተነሳ ነው ቴረሙ ጋር ነበረ። ሶ ከዛ ኤክስፕሬሽን ተነስተን ለፖዚቲቭ ኢንቲጀር ኤን ብቻ የነበረውን ፎር ኤኒ ሪል ነምበርስ ኤን ወስደን ኤክስፕሬሽን ካሳየ ሶ ዲስ ሲሪስ which is binomial series ነው። ሶ the binomial series generalized binomial theorem ያሳየናል። and again ይሄን ከወሰድነው ወደ ፖዚቲቭ ኢንቲጀር ከሆነ ባይኖሚያል ሲሪስ ራሱ reduced to binomial theorem የሚለውን ኤክስፕረስ ማግኘት እንችላለን ማለት ነው። These have a very interesting application. ምሳሌዎችን ስናይ ይሄን እንዴት እንደሆነ ስናይ በጣም ሂውጅ ይመስለናል። ነገር ግን ምሳሌዎችን ስናይ በጣም ቀላል ሆኖ ታገኙታላችሁ። በመለማመድ ይሄን ኤክሰርሳይዝ ማድረግ እንችላለን ማለት ነው። እና say for example here expand each of the following expressions is binomial series. So the first one is here 1 plus x the power of let's say minus 1 because n is now here this series is for n works for the binomial series which is n is any real numbers ስላልነ and again the second part is let's say 1 plus x let's say the power of say half or simply we can say radical 1 plus x. We can expand this. And the third part is just an example here. 1 minus 3x to the power of say minus 5. And again, the fourth example says that let's say 2x plus 3 the power of let's say minus 4. So we can expand all this by applying what we have seen here, the binomial series as a solution. So the first part is here 1 plus x the power of minus 1, which is equals to what would be the expression, the expansion. Using the binomial series, we can expand such kind of mathematical expressions. But here, instead of n, we have to add what the value which is minus 1. So we can say here first replace which is n by minus 1. N is by minus 1. Instead of n, we have to have say minus 1. Therefore, here, the expression says that 1 plus x the power of minus 1 is exactly equals to here 1, here it is plus nx, but n is minus 1, simply 1 minus x. And again plus here n into n minus 1, n is minus 1, so it is minus 1 times of minus 1 minus 1, because n minus 1 the times of say x squared, so which is x squared over 2 factorials plus n times of n minus 1, n is minus 1 times n minus 1 minus 1 minus 1 times of n minus 1 n minus 2 minus 1 minus 2 times of x to the power of say 3 over here it is say 3 factorial plus first of all, which is n is minus 1, and again n minus 1, so minus 1 minus 1, and again n minus 2, minus 1 minus 2, and again n minus 3, minus 1 minus 3, times of x to the power of 4 over, which is say 4 factorial plus in continuing such a way. Therefore, such expression is exactly equals to 1 minus x, and again minus 1 times minus 1 times minus 1 minus 1, which is minus 2 times of minus 1, which is positive 2, so which is say positive 2 x squared over 2 factorial means 2 times 1, which is say 2 plus, and again here negative 1 times negative 1 minus 1 negative 2, here negative 1 minus 3 minus 2 means minus 3, so here negative 1 times negative 2 times negative 3, which is negative 6. So our expression is negative 6 x to the power of say 3 over 3 factorial, but we know that 3 factorial means 3 times of 1 to 3 times 2 times of 1, which is equal to 6, so we have to add here it is say 6 plus here, and again minus 1, here it is say minus 1, here it is negative 1 minus 1, which is minus 2, negative 1 minus 2 minus 3, negative 1 minus 3 minus 4. So when we multiply is negative times negative times negative times negative, which is all this, which is positive, which is positive. So minus 1 times minus 2 times minus 3 minus 4, which is say 24, which is say 24 x to the power of say 4 over here 4 factorial, but we know that 4 factorial means 4 times 1 times 2 times 3, which is say 24, which is say also 24 plus, let's say here x to the power of n, here. But we can express as this, which is, therefore when we simplify this here, 1 minus x, here these 2 by 2 cancel out, so the result becomes here again 1 minus x, which is say plus x squared, minus here is negative 1, which is say x to the power of say 3, and again 24 by 24 is cancelled out, plus which is x to the power of 4, and again plus let's continue in such a way. Therefore our expression is 1 plus x, the power of minus 1 is exactly equals to the series, which is 1 minus x plus x squared minus x cubed plus x to the raised 4 plus continue in such a way. እንግዲህ ይሄ ምንድነው ላይ ያየነው የተባለው የመጀመሪያው ፎርሙላችን 1 plus x the power of n የነበረው 1 plus nx plus n into n minus 1 x squared over to the power of 2 factorial. ለምሳሌ ይሄን ያለበት so instead of n በn ቦታ ማንን የተካነው negative 1 ነው, so here 1 plus, which is negative 1 is n, so which is negative 1 times x is negative x. And again here, n into n minus 1, n is negative 1, so, and again n minus 1, negative 1 minus 1, which is negative 1 times negative, it is negative 2 times negative 1, which positive 2 over 2 is simply x squared. And the next part is here n into n minus 1 times n minus 2 times of x to the power of 3 over 3 factorial. But his n is 1 since minus 1, and again minus 1, which is minus 2, minus 1 minus 2 minus 3. Therefore here we can multiply minus 1 times minus 2 times minus 3, which is minus 6. So minus 6 over 3 factorial, here it is 3 factorial is 6, so minus 6 over 6 is simply 1, so you can express in such a way. Now the expression is 1 plus x to the power of minus 1 is exactly equals to 1 minus x plus x square minus x cube plus x raised 4 plus no እናገኘዋለን ማለት ነው. Therefore we can use the formula. We can expand any mathematical expression for any real numbers having the exponent like this, minus 1, minus 2, minus 5, whatever it is, so we can get such kind of expressions. From this, when we examine whether or not this series is converge or not, so we can see here, so minus 1 minus x plus x square minus x cube plus x, such kind of expression here, recall that. So recall that. So 1 minus x plus x square minus x cube plus x raised 4 plus this is called the geometric specific, which is the geometric series, the geometric series with the first term g1 is exactly 1 and the common ratio r, because common ratio here it is simple. The first term is 1, second term is minus x, so minus x divided by 1 is negative x squared divided by minus x is negative x, minus x cubed divided by x squared is minus x, therefore the common ratio r is minus x. And also you have to recall that the infinite geometric series is converged when the value of r, which is the absolute value of r, is less than 1. So if from this 4 which is absolute value of r, that means in this context absolute value of minus x is less than 1, which means the value of r here is the value of x here is minus 1 less than x is less than 1. So the series converges, which is the value 1 minus x plus x to the power of 2 minus x to the power of 3 plus x to the power of 4 plus all this is exactly converges to the value, the first term g1, which is 1, and the second term the value say 1 minus r, the formula, but r is here the value which is minus x, which is minus x, so the expression is simply 1 over 1 plus x. 1 over 1 plus x is exactly the value which is equal to simply 1 plus x the power of minus 1 ነው እናገኛለን ማለት ነው።